Hi everyone, welcome back to the channel. In today's video, we're going to cover an exciting topic, I would say. And this video is, by the way, a continuation of my previous video where we talked about the creation of a new Solana token called the MAIA coin, or the MAIA token. This token, I decided to create it to reward loyal customers of the application that I'm going to be launching, the e-commerce application I'm going to be launching probably early next year at some point. And the idea behind this token is obviously to reward customers on every purchase. So when a customer purchases, let's say, a couple of bottles of wine, I want to reward them with this loyalty token, which is basically the MAIA token. And this MAIA token in the future will be redeemable for a number of perks and rewards that the customer can get from the shop, from the MAIA Soulful sellers application. And so one of the primary use cases is to obtain discounts on future purchases. And I'm going to take you through the code, the programmatic use of this MAIA token. So you saw in the previous video just the creation of it. I was using obviously the Solana CLI for this purpose, and I've shown you, please, if you've not watched the last video, please go and watch that one first, because this is directly a continuation of that. And if you already know how to create a token with the Solana CLI and the SPL token sort of libraries and all that, then fine, you can start with this one. You don't need to watch the last one. But if you're new to creating tokens on Solana, so I'll definitely obviously recommend that you start on the previous one. So with that out of the way, one other thing, obviously, if you learn anything new in this video, if you like what you're watching, then please consider dropping a like, subscribe to the channel, and hit the notification bell so that you can get a notification when I drop my next video, and obviously also helps other people find this content as well. So, and today actually I decided not to do any slides. This is primarily just a code walkthrough. I will give you a demo of the application. If this recording doesn't run too long, I'll probably do the demo today. If that doesn't happen, like if this is dragging on for a little bit longer than I expected, then obviously I'll do the demo at the very start of the next video, which is so what I had in mind, just to give you perspective. So what I had in mind in terms of how many videos, because this topic of creating a Solana token is obviously a very exciting topic, but it's also a topic that can get very complex very quickly because there are so many areas to cover. And what I wanted to do with the first video was just the creation of the token, which I've done. And now this continuations video, part 2 of the Solana token creation process, I wanted to show. So the first video obviously used, as I mentioned before, the command line instructions to create the token, to add the metadata and all that. We've seen that. Now this one is all about the programmatic use of the token. And when it comes to the architecture and how you architect this Solana application, and I can see many people kind of doing the same type of architecture here, which is you have to consider there is always the client side of the programmatic use of the token, which is basically your DApp, your decentralized application, and there is also obviously the server side of the application. So for the server side, which is what I'm going to show you today, this is primarily, so all the code that you see here, that you're going to see here today, it's actually a code that will run this is kind of an administration sort of backend application or back office application. This is never going to be a public client side sort of application. So all of this stuff will be running in a secure server that is in a private environment, protected by firewalls, all of those things. So typically this code would never be published in an app store, or it would never go into a web app or anything like that. So this is basically running in a private environment, secure environment that I control. So it's very, very different, obviously, from the code that runs in the public client, which is basically either the mobile app or the web app, which runs in an environment that obviously we can't control because it's people's mobile phones or their web browser environments and things like that. So that is obviously one big disclaimer to make here, and presumably you would probably do, like, if you're building an application where you need to do what I'm going to show you today, you'll probably want to run this in a secure environment as well. But as I was saying, sorry, I went off a little bit of a tangent. So the way that I structured these videos was token creation. So that's the last video. Second video, which is today, is part 2, is more about the server, the back office type of environment, which is effectively what I'm going to show you today is really like 3 things. So the first thing is how to listen for events from the Solana blockchain. So that this is really exciting stuff, right? So that is show you how to subscribe to those events. In this case, I'm gonna subscribe to program events for our. So obviously I created my own program, so I can listen to my own program's events, and more specifically, not just all the events, but actually I want to listen for specific accounts that are going to be changed or updated. And for those accounts, I'm going to listen for changes for those account types. So very specific. I'm filtering all of the other program updates out, and I'm just listening for that very specific unique account types that I want, which is basically, in this case, it's the purchase order account updates. So very important. Then once I show you how to listen for those events, the next logical step is to effectively decode the event. So you receive the event, then what you do with it. So you need to decode the event. And once you decode the event, the last and final step so in this case is to distribute the tokens, so the custom tokens that we've created in the last video that I've shown you. Now this is the point where, okay, there is a purchase order coming through, we've listened to that event, and now I want to reward the customer, and I do it on the back of receiving that event. Now you might be wondering, why create this back office application with this type of architect? Like it's a good architecture in a way, because it's completely decoupled from what the client side DApp does, right? Because it's an event-based sort of type of architecture, which by itself, because it's an event-driven type of architecture, it's actually quite scalable. But that was not the primary reason why I decided to design it in this way. The primary reason was security. And with any software application, you always have to have security front of mind. Of course, security should never be just an afterthought. It should always be part of your design when you design applications. But one of the most important things in here is that you want to ensure that you have to consider 2 things. Your client-side application, so anything that runs in a public client, and by public client I mean an environment that you do not have any control over. Again, as I said in the beginning, either a mobile application or a web application. those environments you have zero control over them. You don't know the security measures that those customers have on their machines, so therefore you have to assume that they are not secure. And that code can also be downloaded, decompiled. People can analyze your code. They can try and figure out how the code works. And more importantly, they could even try and get secrets and private keys, etc., you name it, from your code. So that is one of the reasons. Obviously, there are many reasons why you should never have these things in your code. But the point being, it's not safe to have private keys or secrets or anything like that in your code, in your software. Especially, obviously, if the code is a public client or it's part of your application ecosystem that runs in an environment that you don't control. So that was the reason. That was the primary reason why I decided that actually, in order to process these events of purchase orders being updated, I need to decouple the element that distributes the MAIA token rewards from the client side, but also it needs to be decoupled from the backend side. Why? Well, because the smart code also, I would consider it not safe. It's in a public blockchain. People can figure out ways to actually look at the code that is deployed there and extract potentially the secrets and keys if you had them there. So for that reason, I don't want any private keys or secrets on the public client, and I don't want any public keys or private keys in the smart contracts. So that is out of the question. So hence why we need to decouple, like the back office code that distributes the MAIA tokens needs to be in its own separate contained unit, but a unit that actually runs, like this piece of code, is not deployed in the blockchain, it's not in the client side, it's its own separate self-contained piece of code with functionality that distributes the MAIA tokens, that does the reward distribution. Another And why does this code need access to keys? And this is one of the things that I'm going to show you today. As we traverse the code, you'll figure out why exactly. But there are two keys that we need. Two key pairs that we need, public and private keys, of course. One is and the code needs access to those keys in order to be able to sign transactions that are going to be sent to the Solana blockchain. The first one that is going to be needed is the funding key, which is effectively the key pair that is going to be paying for example, the creation of the associated token account in the destination wallet. So this is one that needs to be effectively created and paid for. It's not a lot that needs to be paid for, but still needs to be paid for. And I'm using, for instance, my own programs account, to my smart contract account, to actually pay for the initial creation of the ATA or the associated token account. The other one is the what's the other one? Oh yes, so the other one is the token mint authority. So the token mint authority is the one that owns the initial mint of the token. So in our last video, I told you that, as an example, I minted 200 tokens. And now obviously that 200 is contained in an ATA, an associated token account that sits under the token mint authority. And now the distribution of this is going to go from the token mint authority's ATA account to the destination wallet ATA account. Remember, token transfers, so excluding obviously the SOL, because SOL is the native token of the Solana blockchain, and for that one, you can, it's a different process. But for non-SOL tokens, which is basically the custom token that we've created, this token can only be sent from an associated token account to another associated token account. So what that means is, if you have your total balance that you minted under your token mint authority, that's fine, that's how it should be. But now what you do is you need to transfer from that original account that contains all the tokens you've minted, you need to transfer that to reward your customer. You need to transfer from that ATA account to the customer's ATA account. And if the ATA account on the customer side does not exist, then obviously you need to create it. That's simple. So, enough rambling. Sorry, that was a very big sort of intro. Oh, I was going to say it's a very big introduction, but I almost forgot to say. Part 3, I think I'm going to break this into 3 parts. Today's part 2, which as I said now, we talked about token creation. This is the part where we listen for events. So I'm going to show you the event listening, the event decoding, and then the distribution of the MAIA token. Last but not least, and this is going to be the topic of the next video, I'm going to show you the client-side DApp code that basically culminates in the how do I redeem this MAIA token that I've received as a reward in a previous purchase to now get a discount on this current purchase, right? So, and that closes, we come full circle, right? So we created a token, we reward the customer when they do purchases, and now the customer can use those tokens that have been rewarded previously to now obtain a discount on the next purchase order, right? So that code obviously is going to sit in the DApp, and there is a very good reason why it needs to be there. One of the fundamental reasons, of course, is the fact that now that those MAIA tokens belong to that customer's wallet, only that wallet can sign the transfer of those tokens out of the wallet to get the discount. So as you can see, a lot of the architectural decisions in these decentralized applications often come up because of who needs to sign a certain transaction, and because you don't want to have, for security reasons, as I explained earlier, you don't want to have those keys lying around anywhere insecure. That often dictates how you partition your application so that it remains safe and secure, but it needs to be split into multiple parts that have different responsibilities and different security levels, of course. And as I was just explaining, if what you're signing needs to be signed, let's say, by the customer, obviously that piece of code needs to be in the client-side application, because that means that only that code can trigger the pop-up to come up, let's say, in the Phantom wallet for the customer to click yes, sign, and I approve, authorize. But for instance, in the case of this back office application, I could have the keys in the DApp, but that would be obviously insecure. So, hence why we decided to have it in this back office application, which is never going to go anywhere public. It's going to be in a secure environment. And therefore it's safe for me to load those keys in this code, and therefore, do what I need to do with them to sign transactions and whatnot. One of the other things that I'm going to just say before we before I finish my rambling and we start looking at the really important stuff in this code, is that obviously this code is still it's a quick and dirty thing. It's not production ready. And by the way, I keep saying this, but I'll say it again. before I go to production, of course, I will have to rotate all the keys. So any public keys that you see here, they're not going to be the same public keys in production, even though that wouldn't be too much of a problem because they're public keys anyway. So it's fine if people see them, but just so you know, none of the keys that you see in any of my videos are going to be the same because I'm going to rotate all of them. It's part of just standard, normal, security best practices. You should never, even if I wasn't making YouTube videos about these things, I would still rotate them anyway because it's just, standard best practice. So let's start looking at the code as we have it now. So we start by defining and I'll put I'll put in the video description below the links to a lot of these definitions of for instance, this request payload. Obviously, I took it from the Solana documentation that contains the what I need to send in the WebSockets to get to register to receive program events, and this is obviously taken from that web page with the documentation. So again, I'll put all of the relevant links in the video description below. But yeah, so as you can see here, one of the first things I start doing is I define the purchase order discriminator. By the way, I've shown you what this compute discriminator function looks like in a previous video. So if you want to know what that is, please watch. I believe I put this in 2 or 3 videos ago. So definitely check that out. And so what this does is it creates the byte encoded representation of this purchase order account type. So this is a Solana data account, i.e. it belongs to a program. And obviously it's my program, it's the MAIA sellers program. And yeah, so we'll see where this is used further down. In fact, it's actually used here. So as you can see, this is the request payload, and let's just go through it very quickly. So this is all standard stuff, JSON RPC 2.0, that's the version. ID1, I'm not actually using this for now, but I believe this is the identifier of the WebSocket request. So you can actually terminate this if you want using this number. The subscription, I mean. Then you have the method program subscribe. So obviously there are many different types of methods. So you can for instance subscribe to listen to events about a certain account address, for example, changing. So anytime that account address changes, you get notified. But in my case, I wanted a little bit broader than that. I wanted to actually subscribe to program events, which I think it's probably one of the most useful things that you can do if you have a Solana smart contract. So I said I want to listen for program events. I obviously passed this, the program ID is the long public key address where the program is deployed currently. So you should know obviously what this one is. And now, nothing too spectacular here. I think you probably already know what these are. Encoding, JSON parse. Actually, when I put this JSON parse, it didn't do anything for me. So it's kind of, I didn't see a big difference, but yeah, never mind that. Commitment confirmed. So this is me saying I don't want, if the event is not, let's say if the account update is not fully finalized, it's fine. I want to get notified straight away. Had I put this as finalized, what that would mean is that the events would take a few more seconds to actually hit this code. And when I say the events, I mean the purchase order event. So when someone clicks the button to buy, and all of this, by the way, I'm talking through all of these things, but all of this will, when I give you the demo, all of this will click very quickly. But yeah, so when the buy happens, if I had this as finalized, it would take a few seconds, maybe a couple of seconds more. So for the event to arrive, but because it's confirmed, it's almost instant. Like the moment I click the button, it's like within a second, it's hitting this code. So now this is the other interesting part. So you could have omitted filters. So if had I not put any filters in, what this would do is you get notified of any account changes under your program, which could be interesting, could be another use case. And there is certainly elements of this code that I'm showing you today that you will see at one point. I actually, when I started, and this is something that I recommend you do as well on your end, which is when you start creating this event listening code, actually do not include filters, because if you have an error in your code, you don't know if the error might be because your definition of the filter is actually wrong, and then it's not catching anything. So a good strategy is to actually don't define the filters, run the code without filters, and see what you get. If you start getting bombarded with account updates for your program, great. You know that you're on the right track and you're getting all the events related to your program, which is awesome. And that's what I immediately got. Like I started seeing multiple account updates that were obviously triggered by my actions in the DApp, in the decentralized application. So that was great. And then I said, okay, fine. I'm getting the events now. I'm getting telemetry from the blockchain, from Solana. So now I want to filter that telemetry. I don't want to get all of these notification updates. I want to just get the updates for a very specific account type, which in this case is the purchase order account type. So that's what I'm doing here. So I'm saying, if you remember when I described in one of my earlier videos about compute discriminator, I actually talked about the fact that and I believe the whole reason this happens in this way. I may be wrong, so if you guys know any better than me, please put in the comments in the video description below. I would love to know if I'm wrong on this or not. But I believe the reason this is encoded in this way is because I'm using Anchor for my Solana program, and one of the sort of standards from Anchor is that it writes this account discriminator as in the first few bytes of what we are reading. So in this case, for example, I believe I said it was actually it's the first 8 bytes, I believe, but effectively this is what I'm doing. So I said start at byte 0 because that's where I know for a fact that the account discriminator is there, which represents the account type. And then I said, please compare, like return to me only the accounts that change that match this account type, which is purchase order, which is what you see here. So I encode, I convert it to a byte encoding, which belongs to, which represents the purchase order account type, and then I put it in here in bytes. And then I say obviously that this is encoded in base64. So nothing too extraordinary here, but it's really important that you follow exactly this structure as you see here in the code, because if you do, very likely you're going to start getting your events back, which is the very exciting part. So let's continue. So as you can see here, I connect to the Solana WebSockets. The WebSocket URL, I'm using the one associated with the DevNet environment. This is the standard one. I'm not even using Helios here, for example. I typically use Helios, the Helios RPC for a lot of things, but in this case, I actually didn't need to. It was working fine with just the standard DevNet Sol environment. So yeah, that's what I'm doing here. So I'm connecting to the WebSocket URL. If you're anything like me, you probably only used the RPC URL up until this point. But yes, there is a WebSocket one. If you've never seen it, it exists. If you Google it, you'll find it. Now, one of the things I'm doing here is I'm recording and printing the time the connection opens. And why am I doing this? This is because I found that, and this obviously also explains this piece of code here, so, just before we go into this, so then obviously I connect first there, I record the time that this whole thing starts, and then I send the request payload, which is what we were discussing earlier. I send the request payload through the WebSocket channel. Now, let's talk a little bit about this this element here, the keep alive timer to send a ping every 30 seconds. Why is this? Well, I found that if I hadn't done this piece of code here, which it's like a keep alive. You keep pinging every 30 seconds. I decided every 30 seconds, but probably the optimal time frame here is probably a little bit larger than that. I was a little bit more aggressive here, but again, this is one of the things that I'll have to fine tune before I go to production, or actually maybe I'll just have a chat with the Solana devs to figure out if this is the most optimal way of doing it. Maybe there is a better way of doing it, but this is what I found work. At least it worked for me. So I found that if I hadn't this piece of code here, what would happen is after a few minutes, the connection drops. And the reason I know the connection drops is because obviously I have this, let me show you very quickly. I have this, when the connection drops, it basically writes this subscription closed. So, and I was like within a few minutes of having it open, it was dropping. And the reason for this is because there was no activity on the channel, and I think automatically gets closed. So this is why I had to put that keep alive there. Otherwise, I would, I wouldn't have this code here at all. So nothing too extraordinary here. So I just basically create a timer, and every 30 seconds it triggers this piece of code to run. And if the socket is not closed, then it sends this method ping message to the WebSocket, and because this is doing, keeping the connection alive. Now, let's start. Oh, and one of the things I've also noticed is that if I'm using Helios, with the Helios endpoints, for the WebSocket endpoints for Helios in DevNet, I noticed that if I didn't have this piece of code, with the Helios endpoint, it does remain alive a lot longer than the standard DevNet one. But again, the end result was the same. If I left it too long without any activity, it would just drop the connection. So that's why I decided to basically just put this here, because now I'm going to say I saw it drop once, and I don't know if it was because my internet connection was a little bit flaky and potentially caused the connection to drop. Because I did notice that, like, after a couple of hours, I was testing, in the middle of testing. I had this code running for 2 hours straight. I never stopped it, and eventually it closed the connection. And I was unsure whether that was going to happen again, so I ran it again, left it running for hours, and after almost a whole day of running, it didn't stop. So I'm guessing maybe that happened because I had some internet issue that caused the connection to drop. But I'll need to test this a little bit more to see. Now we are going to talk about the listen. So after you register, obviously for to receive events from a program, the next logical thing you need to do is obviously start listening for those events. So you sent a message to say that you're interested in getting notified when that purchase order account type actually changes. And now when you do listen, you're basically telling, okay, now I'm waiting for something to happen, for an event to trigger. And this is what you're doing here. So you're registering the code, the callback code, or effectively that will be called whenever that event arrives. So let's start by looking at what this code is doing. So effectively, the first thing you need to know is that you receive an event, and when you receive this event, the first thing you need to know is if the event, so you can receive many different types of events here, but the one that you want, and in the documentation, when you look into the Solana documentation, you'll see that the first time you connect to the to the WebSocket URL, effectively, you get like a short message back with the subscription ID and a few other elements. And that is not like, you don't need to do anything with that. It's not the one that you're looking for. The one that you're looking for is the events from your program. That's what you want to capture. So this is what I'm doing here, right? So I'm saying, okay, the events are the program notification events. So these are the ones that I want to actually interpret and process. So that's what I'm doing here. So I'm first looking at the event that I get back, and then the first thing to note is I'm looking for, is there a key there called method? And if there is, that's a good sign. The next thing I'm gonna want to know is the method a program notification? And if yes, then great. I know I have one of the events one of the event types that I'm interested in. And now I'm going to look at the params result objects within that. And then I'm going to look at the value, account, and then finally data. And the first element of that data array. And this effectively contains the base64 encoded binary data that I'm going to have to decode to actually interpret what is in there. So that's what I'm doing here. So I do a base64 decode of the account data that I retrieved from the JSON object that I received from the WebSocket connection. I then call this decode data. This decode data is very similar. I'm going to show you now, but this decode data is very similar to the one that I've shown you, I believe, 2 videos ago. So in that video I've shown you all of this, but effectively I get the data, which is a sequence of bytes. And in this case, for instance, I simplified it a little bit. I was getting, because of my particular example, I was getting account, like before I had the filters on for the purchase order account type, I was getting 2 types of accounts being updated, which is obviously expected for my particular specific application, because the application updates 2 accounts when the purchase order is submitted. The application submits 2 updates, one for the admin account types and one for the purchase order account types. But obviously then when I added the filter, it's filtering everything out except the purchase order, which is what I want. So, but anyway, this decode data is doing that. It's basically looking at the different account types that I'm expecting to receive. And if, sorry, when I receive one of these types, I basically just deserialized the binary data to the actual object type, which could, in this case, would be the either the purchase order or the admin account. But obviously, because I added the filter, it's only the purchase order. So let's go back to where we were. All right, so this is the decode data. So as you can see here, this is what I was checking. Obviously, I'm going to when this code is production ready, it's only going to be purchase order that I'm going to have here. I'm not going to have the admin here probably, so I'm going to remove that. But effectively, yes. So as you can see, I'm saying, okay, is this a purchase order? Okay. And then print the purchase order, details on the console output. I'll show you this when when I do the demo. You'll see the data coming through as the events are triggered, and then I basically call a function to reward the customer. So I pass into the reward customer function, which I'm going to show you in a minute. I pass on the purchase order object to reward the customer, and effectively the only thing I need from that purchase order is actually the wallet, the customer wallet ID, because everything else in there is no, not actually. There may be one other thing that I will need from there, which is the purchase amount. But anyway, I pass the purchase order into the reward function. And finally, if the reward customer was successful, I just print to the console success rewarding customer. Otherwise, I say did not have any success doing that. I do the same thing for admin, but as I said, admin is no longer being filtered out, so this code is never going to execute. And then finally, I have this, I have this print basically to say if this is not a program notification type of event, then basically just say non-notification event received, and then I'm printing just for my knowledge what type of event that is if it's not a notification. So you'll see when I run this program in the demo. You'll see the first one that we receive is actually one of these because it's not a program notification. It's basically just the WebSocket returning yes, subscription accepted, and this is the ID associated with your program subscription, or for your registering to receive program updates. Yeah, and this is basically for the WebSocket. If there is an error, I want to print the error in stack trace, and if the WebSocket is closed, I want to say that to print also that event saying that subscription was closed. I print the time that it was closed and then the duration that it remained open. Again, I added these things because I noticed that the connection was dropping. So for my own understanding, I wanted to see if the timing was always the same. Like, is it only remaining open for 5 minutes or for 2 hours? And so that, to help me troubleshoot. So I highly recommend you do something similar to this so that if your connection drops, at least you can see if there is a pattern there. Like, does it drop every single time after precisely 2 hours, or is it a little bit more random? At least, again, as I said, helps troubleshoot. And obviously, if there is an error, it cancels the subscription, which is always a good thing to do. And we can ignore the rest of this because this is just launching the Flutter app, which I'm going to remove anyway. This is not going to be likely, it's not going to be even a Flutter app at all. So so now what I need to show you to finish this video, which is already running a little bit long, I'm going to show you the reward customer. All right, so up until this point, what did we do? We said we want to receive events. So we sent a request payload to the WebSocket channel saying, please register this application to receive events from this program ID and actually filter out everything that comes my way. I'm only interested in processing the events related to purchase order account types. That's what we've done. We registered this program that is going to run this back office admin application to just be listening for updates for that account type, for purchase orders in my case. And now, and obviously the second step was to decode. So we receive the event, we listen, we receive the event, and we decode the event to the appropriate account object type, and we determine what's inside. Now that I've done that, now it's time to do the thing that we wanted to do, which is reward the customer for the purchase order. This is the loyalty element of it, right? So we created the MAIA token in the last video, and now distribute it. So let's go through the code that does exactly that, obviously programmatic way. So as you can see here, I received the purchase order received object type as part of the argument. This was obviously taken from the event. So I would decode the event to get this object type. And as you can see, the first thing is I retrieved from the purchase order customer wallet address. I get the wallet address and store it in there, right? So I have to create this object, which represents the wallet address of the customer. Then I create two objects of this type to hold the key pair, which is basically the public and private key, associated with two, as I mentioned in the very beginning of this video, associated with two things. One is the funder. So who is going to pay for the creation of the ATA account? And then the other one is the token mint authority key pair, which effectively is needed to sign the transaction that allows the number of tokens that I want to transfer to the customer to be taken from the token mint authority's ATA account to that customer wallet's ATA account, right? And just to, in my last video, I mentioned what the ATA accounts are and why they're used, but effectively, it's a special type of PDA, right? So you're under the Token 2022 program, which is the program that we used to create this MAIA token, we created a special kind of PDA called ATA, Associated Token Account. And obviously, the first ATA that we created in relation to the MAIA token was the Token Mint Authority's ATA. And now we are going to create the customer wallet's ATA. And this will be the same for every single customer going forward, right? So that all the users of my application will have, when they do a purchase, when they get buy a bottle of wine, they'll get a reward, and the reward will be in the form of my tokens, which obviously can then be used to redeem those tokens in future purchases to get their discounts. And I will say I had a fantastic, I'll probably do a video just on this to explain the token, not the tokenomics, but more the idea behind how this MAIA token is going to be incredibly valuable and potentially even linked to the Sol tokens growth. But anyway, this is just, I'm cooking some ideas here, and it's going to be really fun to kind of implement these. And, as I develop these things, I'll obviously let you guys know. And who knows? Maybe in the future, some of you will actually use these MAIA tokens in the future if you are a white lover like I am. Sorry, I'm a little bit. I've been recovering from a flu. Let's put it like that. So apologies in advance for any future coughs during this presentation. Really sorry about that. So yeah, so these are, as I said in the very beginning of the video, the two sort of key pairs that I need. One for funding the initial ATA curation, and then obviously the other one that is required to take the tokens from the Mint authority to be able to send them to the customer wallet. So one of the things that I wanted to mention here is that while for Flutter, I mentioned this before, when I decided to start creating this decentralized application, I had two choices. Either go with the box standard one, which everyone uses, which is just use your JavaScript, flavor of the day to client-side libraries to access the Solana blockchain, which is what like 99 probably percent of everyone that is developing decentralized applications. This is obviously me speculating, but I'm guessing a lot of people are using the JavaScript libraries, which is fine. There is no problem in that. I decided to use Dart, as I keep explaining, because of the cross-platform nature of Dart and Flutter in this case, the Flutter framework. Because I wanted to just have a single code base to run mobile, web, etc. Even desktop, I can even be run on desktop. So yeah, so and what this means is that the library support for Dart is not as good as for JavaScript, primarily because the people, I guess, again, this is speculation on my part, but I'm guessing the people that develop the libraries that I'm using here, they're not obviously keeping them updated as often as probably they should. And so some of the stuff that already is updated in JavaScript libraries and is readily available, and I'm guessing the Solana team, provides new updates to those libraries every so often. If they are the ones that produce most of them, again, speculation. I'm not sure. I'm not sure if that's the case. For Dart, that's not the case. So what I noticed is that in some cases, for instance, this particular one where I call has associated token. So when I call this method from the Solana client on my case, this one actually works fine, but I found that others that don't, and I'll show you. And what that meant was that I had to learn how the library actually, the inner workings of the library, and this code that I'm going to show you now is actually a little bit, has a few more steps than you would normally have had the library worked to perfection with the Token 2022 program. Unfortunately, the Solana libraries for Dart do not have this working, fine-tuned and working to perfection with Token 2022. They do work probably very well for the previous version, like the original token program, before the token extensions kind of were added to Token 2022. So what that means is effectively I had to basically understand a little bit deeper what their library was doing, and then I had to not reverse engineer, but I had to basically figure out like what elements of the original library I needed, and then I had to reconstruct it here on my code. But anyway, this code works, so that let's get to it. By the way, I didn't mention this, but this is the I would never obviously put like so these files that I'm loading here from the assets in the in Flutter case. Again, this is only relevant if you're using Flutter, but even if you're using other application types. So what I did was I embedded the key pairs in this administration application. But again, as I said, this administration application is not going to go anywhere. It's going to remain in a secure server. So that's why I'm a little bit more easy going with, having these key pairs here as bundled in the application code, but I'm not even, putting this application anywhere. So anyway, this is safe for the time being, but I just wanted, to mention this because you guys should not do like any application that is going to be in an environment that is not protected. You should not do what I'm doing here, right? So again, disclaimer. Application security is super important, and it's fine to do things like this when you're in development mode and testing, etc. But even then, you should obviously put in these things in repos, and so it goes without saying that all of these things related to security, you should always take them extremely seriously, even if you are in a test environment. Always take them seriously and always consider the implications when you're going to production. Okay, with that out of the way, let's continue. So yeah, so the first thing that I need to know is, does this customer that I'm going to distribute tokens to, do they have an associated token account? Yes or no? If and this is what this RPC call is kind of doing, right? So it calls, has associated token account, it passes the customer wallet and the mint. The mint is again, if you watch my previous video, I talked about like this is the token definition address. This is where the token is defined, and it's basically saying, can you find an ATA for this customer wallet address for this token mint address? And the other thing I'm doing here is I am finding the associated token address for the customer wallet. In case it does not exist, I will need to create it, and this is what this line is doing, right? So it's basically saying derive an address which obviously these are the seeds effectively. If you remember PDAs, you generate PDA program derived addresses from certain number of seeds. This is effectively what we're doing here. So we one of the seeds is the customer wallet, the other seed is the mint address or where the token is defined. So this is obvious. And then the token program type, this is the token program, the token 2022 address, which also is part of the seed. So if you combine these three seeds, you will get a derived address, which is the customer wallet's ATA account. And as you can see here, if no hash token, i.e. if this wallet never received the MAIA token before, then I print this to the console customer wallet, and then I print the wallet address. It does not have an ATA. So now I'm going to create the ATA, and I'm going to use that derived address for that, right? So this is what the associated token account instruction, create account. So this is one of the important steps. So I create the account with for the mint address, for the derived address. For this, so this is the destination ATA, the customer's ATA. The owner, obviously, it's the customer wallet, makes sense. The funder, so this is who is going to fund the creation of this ATA. So I'm saying the funder is the program my program effectively, the smart contract is going to be the funder of this. And then it's the program ID, which is the token 2022, which is the one that we've been using, and the one that, when I created the MAIA token via the CLI, it basically was using this program ID. If you remember, one of the instructions to create the token explicitly mentioned this token 2022. And the ID actually is showing in both in the Solana documentation, which I'm going to provide you the link for, but it also shown in my last video in one of the slides. This address, this long string address, was there as well. And now this is the final step, right? So you've constructed the message to create the ATA for the customer wallet, and now you send it, right? So you put the instruction inside basically a transaction, a message, and you say who is the signer, which is the funder, which is in my case it's the key pair associated with my smart contract. And now you can say, so in this case, I'm actually saying, I want to wait for the finalization of this transaction. I'm actually not just doing confirmed, I'm actually going to I want to make sure that the transaction is final, immutable in the Solana blockchain. And that's what this is about. Now I'm saying, as you can see, print the ATA. I'm saying ATA created successfully, and more importantly, if you want to verify that this is a transaction signature, so you can search on the Solana Block Explorer. You can go and search for the transaction signature. And this is the ATA that was created because it was the one that we derived above with those three seeds, if you remember. Now, this one here, I didn't need this. I only included this here for demonstration purposes so that you guys can see that this is also possible. So I included here an RPC call to get the mint details. So if you provide your in your programming language of choice, probably JavaScript, but maybe others, who knows? Maybe you're one of those like me that decided to use another type of language like Dart. But in my Solana client library, I have this get mint RPC method, and you provide the address of your token, and you then get some details. So you get the token address. So in this case, I'm printing the token address, the decimals of the token. So in my case, it's 9 decimals for the token. And I'm printing the supply of the token. So yeah, nothing too dramatic here. And then what else am I doing? Yes, so I'm extracting the MAIA amount from the purchase order. So purchase order total price times 10 decimals. Right. Yeah. Effectively what I'm saying here is I want to transfer. So I put some like really simple logic. This is not probably going to be the final logic, but I put some really simple logic which says, let's say if you spent 0.5 SOL to purchase a couple of bottles of wine, I am rewarding you 0.5 MAIA tokens, roughly that. So I'm saying whichever amount of SOL you spend, I am rewarding you the same number in MAIA tokens. Yeah, and this is just formatting. Because don't forget, like these are, it's almost like it's the same thing as so it has 9 decimals, so that's why I'm formatting it like that. What else am I doing here? Yeah, so I am getting the ATA. So I could have hard coded this. Again, if you don't want to, for performance reasons, for example, you want to make this run like be super optimized for performance, you could avoid doing this RPC call because you could just hard code the ATA for your mint authority in the program itself. I could have done that, but I just wanted to show you that you can also do this programmatically by calling an RPC method. And so in this case, I called get associated token account, and I passed the token mint authority public key. Again, the mint, of course, makes sense, and the commitment level. And this basically returns the ATA account under the token mint authority, which basically contains all the tokens that were minted in the first place. Yeah, so this is obviously, I never expect this code to be executed, but it could be for some if there is a really massive issue. But yeah, so the the token, the ATA should always exist, of course, for the token mint authority, because if it didn't, then it means that I forgot to create the token, which would yeah. But anyway, you should have obviously your code check that. And obviously then I print it. You can see I print the mint authority ATA account. And now this is the most important part of this whole thing, really, which is I create a token transfer instruction. And as you can see here, I'm defining the source. So I'm saying, please transfer the MAIA token from the associated sender account, which is again the token mint authorities ATA account. So that's the source. The destination is the derived address. The derived address is again the ATA account that we either created or already existed ATA account for the customer wallet address. So that makes sense. Owner. So the owner, of course, is the token mint authority, because that's the source that the tokens are coming from. So they're coming from there and into the customer's wallet. The amount, so I've shown you earlier, so I calculated that by amount. In my case, simple logic, I'm just saying whatever amount of SOL that was spent in the purchase, basically just convert that, like give the customer an equal amount of my tokens. And the token program. So I believe this is the reason why when I did some of my research of why the library was not working for this, I believe it was because the library was using the old token program as opposed to the token 2022. So I had to basically do these steps more granular in a more granular way in my code. Otherwise, all of these steps would have been automated by a single. I'll show you in a minute what, like the one that didn't work for me. Maybe in the future, when they update the library, all of this will work, and therefore I don't need to do all of these very granular steps. But actually, I'm glad it didn't work, because at least it helped me understand this in a more finer way. Yeah, so it forced me to really go deep in the weeds and trying to understand how this works. Yes, as you can see here, I create the message, I hit the transaction with the instruction inside. I didn't use the memo. This is an interesting one that, I found this in a piece of code somewhere. I left this commented here, but with the objective of actually uncommenting this and just testing it out, but I didn't have time yet before the recording of this video to actually test it, but I will definitely want to test this. This is a cool thing that you can do. And yeah, so this is the final step. So now that I have the transaction encoded to create the, to send because the customer now has an ATA, I can send the transaction over. And yeah, and this is the message. So the message contains that instruction to transfer the tokens. As you can see, the signer is the token mint authority. So this is why I needed this piece of code to run in a self-contained sort of secure environment, because this needs to be signed by this code. And yeah, I'm just waiting for a confirmation from the blockchain, not going to the finalized stage, but at least confirmed is good enough for me in this case. And I want to get confirmation that the transfer was successful. So this piece of code that you see here that is commented out, this is what I was expecting that it would work, but it didn't. So I believe, so this Solana client dot transfer SPL token. So this, if any of you are using Dart like me, this is the one that didn't work for me. So I had a Solana client. I found that this transfer SPL token did exist. But when I try to use it in this way, by specifying the mint, the destination, the amount, and the owner, which is the token mint authority. When I tried to do this, it didn't work. And I believe the reason it didn't work was because when I looked inside of this and I started digging deeper, I found, I believe that the mistake was that they were not really handling the token 22 program that well. So I had to take some of the elements of the code that they had and put it in here and kind of call things more, as I said, in a more granular sort of step-by-step way, because a lot of these steps should have been sort of taken care of by that transfer SPL token. But anyway, I'm going to remove this actually now from here because I don't need it, but I just wanted to leave it here just so you know it exists, but it's misleading because it doesn't work. At least it doesn't work for token 2022. Yeah, so we are at the end really. So I just, yeah, I print the transaction signature that I received from calling send and confirm transaction. And then, yeah, and then if I actually haven't had an error yet, so I don't know if this piece of code actually is gonna work. I will have to probably, if I don't get an error anytime soon, I will have to trigger an error myself to see if this is, how that does that. Like, does it return an empty string or does it return some other thing? I don't know. But it's because when I go to this, it does say that it returns a string. So yeah, I was wondering what happens if the transaction fails for some reason, does it return an error here? Anyway, point is, I'm saying if it's different from an empty string, then succeeded transferring, and then I basically just make a summary of what was transferred, like I transferred this amount to this customer wallet on this ATA account, and that's it, really, guys. I think I've done enough talking for this video, and yeah, I hope you found this useful. And in summary, what we've discussed in this video, I think it's a really exciting topic, and it's one that I've been looking to do myself. And apologies, I took a little bit longer to publish this video. Real life took over, lots of things going on. I was actually also sick as well, as you saw. Apologies for my coughing at some points during the video. But the point is, I was really excited doing this. This is like one of the really great use cases that any business would obviously want to do, which is listen for events on the Solana block, register to listen for a specific event of your program, and in my case for specific account type updates on that program that I wanted to receive. Then I've shown you how to decode those events and deserializing from that binary format, the Borscht that we talked about in previous videos, the Borscht type formatting type, decode them into a useful type in your application. And then I've shown you the programmatic distribution of the custom tokens, the MAIA tokens in my case, the custom tokens that we've created in my last video, right? So we are now saying when we receive a purchase order, now distribute these tokens to my loyal customers. And in this case, I've implemented a very simple logic which says, if I've spent one SOL, please provide one MAIA token as a reward for this customer wallet, right? In my next video, what I'm going to show you is how to spend these tokens, right? So I've shown you the back office application that distributes the tokens to the customer's wallet. I've explained, obviously, in the beginning, the architectural decisions around this, which were primarily security reasons that resulted in this decoupling from both the client-side DApp and the smart contract Solana on-chain sort of program. So this third component was needed primarily for security reasons, but also scalability as well. The application becomes way more scalable when it follows event-driven architectures. So now in the next video we're gonna do the really also an exciting one that is coming, which is effectively the decentralized application client side of things, which enables the customers now to spend these tokens that they receive to obtain fantastic discounts, of course. And not only that, but you're also going to see the demo. So I'm going to bring all of this code to life by showing you a demonstration of this code that I've shown you today, the back office application. I'm going to call it that. The back office application, admin application, is going to be running and printing on the console whenever it receives the events, and you're going to see the events in real time. And then I'm going to show you the mobile app, which I didn't run today. It's on the screen, but I didn't run it. I'm going to show you the mobile app, and the mobile app is going to be used to basically just purchase, trigger the purchases so that you can see the events coming through. But not just that, you're also going to see the next code that I said that I'm going to show you, which is effectively the code that redeems the MAIA tokens and allows the customer to spend those tokens to get that benefit of the reward, of the discounts, let's say. And that's it. I hope you guys enjoyed this video. I know it was a long one. It was a lot of code to go through, but I hope you found this useful. And again, as I said in the beginning, please consider dropping a like, subscribe, and hit the notification bell to get notified of my upcoming video, which is again going to be part 3 of this token creation process, and not just creation, but also distribution and how to use programmatically these tokens that I think it's fair to say that we are going to revolution, like blockchain-based loyalty programs, I think are going to just take over the world. And the old legacy loyalty programs, like the ones that you see from airlines, for example, is a good example, like the airline points programs and things like that. This can all be done in blockchain. And the beauty of this is, sorry, I'm just going, I was supposed to just have finished, but the beauty of this is you can even transfer these, like, if you want to gift some of your points or some of your coins, MAIA tokens, for example, to your friend as a birthday gift, you can, right? So this is almost like buying someone a voucher, but now it's all digital, right? So you can transfer these tokens to them, and they can use these tokens to obtain discounts when purchasing the wine, for example, in this case. So if they're a wine lover, they'll love your gift of a voucher, but it's not a voucher. You're giving them your precious MAIA points that they're going to be able to use to get those rewards. So it's fantastic. It's great. I really truly look forward to the very near future to see all of these beautiful blockchain-based use cases that actually make it, they are a perfect use of this new technology. And it means that you truly own your loyalty rewards, and they're not like part of the centralized sort of company's sort of website that you lose. I once was, I had some points that I had accumulated for so long, and then they got wiped out and I never got them back. This was actually with an airline. And I was so frustrated because I had quite accumulated over the years so many points that I had never used. And it was frustrating because I couldn't recover them, even after a number of calls. But anyway, I hope you enjoyed. And I'll see you next time in the part 3 of this video. Goodbye. Thank you very much.